Sathyabama Institute of Science and Technology.
Warm welcome to everyone listening to this video. I am Dr. F.V. Jayasudha, Associate Professor, Department of ECE, Sathyabama Institute of Science and Technology, deemed to be University, Chennai. In this video, we are going to look on the topics S matrix, its properties, its method of analyzing, and we will take one of the microwave components, how that microwave component can be analyzed using the S parameter matrix. So before going inside the lecture video, let us see what is microwave. Microwave is nothing but, as the name says, micro, very small. So small wavelength or short wavelength electromagnetic energy which is radiated from the source to the destination. So why do we call it as the microwave, or it is also called as the millimeter wave? So it is basically dependent on the formula wavelength lambda equal to c divided by f. Lambda is wavelength, c is velocity of light, which is given by the value 3 into 10 power 8 meter per second, and f is the operating frequency of the antenna. So when we take the microwave or microwave energy, the frequency range comes from 300 megahertz to 300 gigahertz. For example, if you take the value 300 megahertz and substitute in the formula lambda equal to c by f, we get the value of wavelength, the distance, to be 1 meter. When we take the other boundary 300 gigahertz, the lambda value comes out to be 1 millimeter. So as the frequency goes on increasing, the distance goes on decreasing. So that is one of the reason why it is called as short wavelength or microwave or millimeter wave. So regarding the properties of the microwave, it has lot of properties as it is stated here. So they are the electromagnetic energy operating in the short wavelength. They are not reflected by the ionosphere, and it is very easy to be attenuated at short wavelength, and it is used for lot of applications. So some of the applications of microwave are, as we said, it is a short wavelength or microwave energy of radio frequency ranging from 300 megahertz to 300 gigahertz. It is used for point-to-point communication in much of the applications like satellite, radar, biomedical applications, etc. So now when coming to the concept, what is S parameter, what are the properties of S parameter, how to interpret the S parameter values, and how it can be used for analyzing the microwave components. So any network whatever we take, it can be represented as a port. So it can come under any of the categories like a single port or double port, what we call it as two-port network, or multi-port, more than two-port network, it is called as the multi-port network. So the representations are as we see here. So this is our one-port network, two-port network, and the multi-port network. So any electrical system which has input and an output, a source and a destination, it can be analyzed using any one of the port concept. So here if we see all the multi-port, networks which are operating at a low frequency, that is any circuit or the network which is operated at the low frequency or being analyzed using the low frequency parameters. Some of the low frequency parameters are impedance parameter, which is represented as Z parameter, your admittance parameter, Y parameter, then hybrid parameter, H parameter, and ABCD parameters. These are all the parameters which are used to analyze a network or a circuit working at low frequency. So when the frequency goes on increasing, as we say it to be a microwave frequency of electromagnetic energy, these low frequency parameters cannot be used. So what is the reason why these low frequency parameters cannot be used for analyzing a microwave range of frequencies? The reason are, when we go to the low frequency parameter, every time it is analyzed in terms of voltage and current. That is, either the input side or the output side is open circuited or short circuited, and the equations are represented in terms of the voltage and current, and then the analysis is being done. But when we go to higher frequency ranges, these voltage and current representation or short circuit or open circuit representation becomes unstable. So it is very difficult to understand the interpretation or meaning of a high frequency component. So that is the only reason we go for the alternate. So what is the alternate? To analyze the high frequency parameter, we go for a parameter known as S matrix, scattering matrix. S stands for the word scattering matrix. So these scattering matrix have a different representation and certain properties which has to be satisfied in order to analyze any microwave component. So let us see what is scattering matrix, why we are going to use it, and what are the representation coefficients. What is S matrix? So normally S matrix is used to give the relationship between input and the output port of an electrical system. So whenever we take a S matrix, there we represent in the form of power, not in voltage or current as we do in our low frequency parameter. Here the representation is done in terms of the power parameter. So when we call it as a power parameter, we talk in terms of the waves. So what are the waves associated with the high frequency analysis? They are the incident wave, what we call it as input wave, exiting wave, what we call it as the output wave, and the reflected wave. So what is reflected wave is, whenever a signal enters a particular port and it is not able to come out of the output port and it comes through the same port itself, that is what we call it as reflected wave. So the entire S parameter is done in the form of wave analysis as incident wave, exiting wave, and the reflected wave. So as we see in this screen, so this is a port which has two ports in it, and the center one we call it as the DUT, device under test. It has port 1 and the port 2. Each and every port has two terminals. So as we see here, the port 1, the terminal is represented as A1 and B1. A1 is nothing but the input terminal, B1 is the output terminal of the port 1 itself. The same way, if you see the port 2, it is A2 and B2. A2 is the input terminal of port 2 and B2 is the output terminal of port 2. So totally there are 4 terminals and 2 ports in this particular analysis. So what is the meaning of each and every ports? So whenever we take it as the S matrix, based on the number of ports, the matrix is decided. That is, whether it is a 2 cross 2 size or 3 cross 3 size based on the number of ports. So when we see here, I have taken an example of a 2-port network. So when there is 2 port, the size of the matrix will be 2 cross 2, n cross n matrix, S square matrix. So when there is n cross n, 2 cross 2 matrix, there will be 4 parameters to be analyzed. So what are the 4 parameters related with our S matrix? They are S11, S21, S12 and S22. What is the meaning of the numbers? So when you take the S11, the first number represents the output port. The second number represents the input port. So what is the meaning of S11 is, the signal is going to enter the port 1 and it is going to come out of the same port 1. So that is the meaning of S11. So now let us see the second parameter, S21. Meaning of S21 is, the signal is going to enter through the port 1 and it is going to take an exit through the port 2. Okay. So if you see the S12, signal enters through port 2 and exits to the port 1. And S22 means signal enters through the port 2 and it comes out of the port 2 itself. So here, what is the meaning on the names given for each and every representation? So now if you take the S11, so as we said, the signal enters to the port 1 and comes out of the port 1 itself. So the input terminal is A1 and the output terminal is B1. So the signal has not gone to the port 2. So it is called as reflected wave. That is why the S11 is called by the name reflection coefficient. The same way, if we go and see S22, the signal enters through the port 2, comes out through the port 2 itself. It is not going to the other port. So that is why it is called as reflected wave again. So it is called by the name reflection coefficient at the port 2. So if we see the parameter S21, meaning of S21 is, signal enters through port 1 and goes to the port 2, meaning it is going in the forward direction. From 1 to 2 in the forward direction, signal is being accepted. So it is given by the name forward transmission coefficient. If you see the parameter S12, signal enters the port 2 and comes out of the port 1. So from 2 to 1 when the signal is coming, it is coming in the reverse direction. That is why it is called by the name reverse transmission coefficient. So that is what is represented in the slide also. So when the wave is coming through a particular port or entering through a particular port initially, we call it as the incident wave. The wave is coming out of a particular port, that is called as the transmitted wave or the exiting wave. When the wave is being reflected in the same port, we call it as the reflected wave. So now these are the S parameter representation. If you see here the same 2-port network, 2 ports 1 and 2 is there and 4 terminals A1, B1, A2, B2 respectively in the input and the output port is there. And how we represent the equation for the S parameters is, we normally write it as voltage in terms of the current in our Z parameter or Y parameter. So in case of this one, it is represented as output terminal in terms of the input terminal. So B1 is the output terminal of your port 1 represented in terms of the input terminal A1 and A2. So this is how it is represented. So now if you see this is the S matrix, how to represent the S matrix. So if it is a single port, then it is 1 cross 1 matrix. The size is 1 cross 1 matrix. So it is represented as S11. If it is a 2-port network, size of the matrix is 2 cross 2. So totally it will be having 4 parameter coefficients in it. So it is represented in the second way. If it is a 3-port network, it will be represented as 3 cross 3 matrix as it is represented in the third way, and etc. It goes on like that. So what are the properties of S matrix? Whenever we want to analyze any microwave component, it has to satisfy 4 important properties of the S matrix. The first important property is, based on the number of ports we are going to take and analyze, we have to decide the size of the S matrix. So always the number one point is, the S matrix takes the square matrix. If it is a 2-port, 2 cross 2 matrix. If it is a 3-port, 3 cross 3 matrix. The second important property is, it is a symmetrical matrix. So as it is rightly stated here, Sij is equal to Sji. For example, if you take the parameter S13, its symmetry property will be S31. So we can tell that S13 is equal to S31, S23 is equal to S32. So they are like a mirror image property, so we call it as the symmetry property. The third important property is your unitary property. So unitary property states that the S matrix multiplied or product of S matrix with the conjugate is equal to unit matrix. What do you mean by unit matrix? The diagonal terms will be taking the unit value 1. So now let us go into one of the applications. As I said before, we are going to see the microwave component. The microwave component taken in this lecture is microwave Tee junctions. So what is a microwave Tee junction? Why it is needed? So as you can see in this diagram, the center part is what we call it as the microwave junction. If you see it clearly, it looks like a traffic signal. So in your traffic signal with the 4 roads meeting together, the vehicle can come from any direction and it can go through any other direction. The same way, the signal can enter in one of the port and it can exit in any one of the port. So any other ports can take any of the applications according to the customer's need. So when we take a microwave junction, it can serve a lot of applications in satellite, radar or point-to-point communication, etc. So that is the main application of our microwave Tee junction. So they can act as a power divider, they can act as a power splitter, they can act as a duplexer, they can act as a mixer also. So here we are going to see about H-plane Tee junction. So what is H-plane Tee junction? So if you see in this diagram, this is the practical one what we can have in our lab also. So this is the way the Tee junction will be looking like, and this is the equivalent circuit of the Tee junction. So what is a H-plane Tee junction? A normal rectangular waveguide will be taken and another rectangular waveguide will be connected in a particular format. So here in the H-plane T junction, along the magnetic field in a shunt format, the another rectangular waveguide will be connected to a normal existing rectangular waveguide. So a normal rectangular waveguide has two ports, port 1 and 2. So if you see this diagram, this collinear arm is a rectangular waveguide which has two ports, port 1 and 2. Another rectangular waveguide is connected in shunt to your normal rectangular waveguide, and that is our side arm port 3. So whenever the port 3 is connected along or parallel to the magnetic field, it is called as the H-plane T junction. So what are the various properties that has to be considered when we are going to analyze the S matrix? So some of the properties of our H-plane is, whenever a signal enters through the port 3, we call it as the side arm. Whenever signal enters through the side arm, it is equally splitted in magnitude and in phase with each other. So along the port 1 and 2. So whatever signal is entering port 3 will split equally in magnitude and in phase and goes through the port 1 and port 2. So that is the main speciality of our H plane, and it makes a difference with the E plane also. In our E plane, what happens is, whatever signal is entering the port 3, they will split equal in magnitude but will be 180 degree out of phase with respect to each other. So that is the basic difference between a H plane T and a E plane T junction. So here if you take, so we are going to apply each and every three properties what we have seen for our S matrix properties. So what is property number 1? Property number 1 is it should have a square matrix. As you can see from the diagram, it is a 3-port network. So 3-port network means our S matrix is going to be of the size 3 cross 3 matrix size. The second important consideration is from the concept. What is the concept we have seen? The signal enters the port 3, divides equal in magnitude, goes through port 1 and port 2. So meaning is your S31 or S13 is equal to S23. So these two S parameters will be equal. So next one is the possibility is 3 cross 3 matrix. So now we have to frame the matrix, solve it, and we have to give a conclusion. So what is the second important property? It is the symmetry property. So symmetry property is Sij is equal to Sji. So here if you see, according to that symmetry property, S12 is equal to S21, S23 is equal to S32, S13 is equal to S31. This is our symmetry property. And what is the third property? It is nothing but applying the unitary matrix. So before applying the unitary matrix, we are going to frame the matrix. So the S matrix for a 3-port H-plane junction is these matrix. So in the first row we have S11, S12, S13. The second row we have 21, 22 and 23. And the third row we have 31, 32 and 33 suffixes. Okay. In this S matrix, we are going to apply all the characteristics what we have seen for a H plane. So first important characteristics is the signal is going to split equal in magnitude and in phase. So according to that, what will happen? S13 is equal to S23. The second property is symmetry property. By symmetry property, 1, 2 equal to 2, 1, 3, 2 equal to 2, 3 and your 1, 3 is equal to 3, 1. So normally if you take this S matrix, it has 3 cross 3. That is totally 9 parameters to be analyzed. But when you put all these characteristics in the S matrix, the number of components what we need to analyze will be reduced. So let us see that. So this is the reduced matrix after applying all the characteristics of the H-plane T junction. So if you see here, S11 remains the same in the first row, S12 remains the same. So if you see, the first row remains the same, they are the common parameters. Coming to the second row, S21 can be written as S12 by symmetry property. S22 remains the same. Next is S23. S23 can be written as S13 according to our characteristics of the or important feature of our H plane. And then if you could go to the third row, S31 can be written as S13 and S32 can be written as S13 according to the characteristics, and last one is S33. So if you go to this S33, normally in our H plane or E plane or magic T, the side arm will be perfectly matched. What is the meaning of perfectly matching is, whatever signal enters through that particular port will not be reflected in the same port. That is the meaning of perfectly matching. So when reflection is not happening, S33 of that particular port will be equal to 0. That is why S33 is made it as 0. So now by applying the third property, that is unitary property. So unitary property is S into the conjugate equal to 1. So you are going to take the product of two matrix and make it equal to 1. So what we are going to do is, we are going to expand the row and the column and make it equal to the unitary diagonal 1 value. So when you are doing R1C1, that is you take the product of row 1 and column 1, which is made to 1, which is equation number 3. Then row 2, column 2, when we write the equation, you get the equation number 4. Then row 3, column 3, when you expand, you get it as S13 square plus S13 square equal to 1, equation number 5. And then finally, we are going to do row 3 and column 1 and make it equal to a symmetry value, that is 0. So these are the new equations what we get. So when you solve these equations, we will get the values of each and every parameter present in your S matrix. So how the solving is being done is, you have to equate the equation number 3 and 4. That will give you S11 equal to S22. Then you have to take the equation number 5. That will give you the value S13 equal to 1 by root 2. And you have to equate the equation number 6. That will result in this part, where S13 into this combination equal to 0. So just now we found that your S13 is equal to 1 by root 2. So practically S13 cannot be equal to 0. So that is why the remaining expression becomes 0. So we get the relationship S11 equal to minus S12. So these are the final answers what we have got by equating each and every equation starting from 3 to 7th equation. So the answers are, your S11 is equal to S12, S11 answer is equal to 1 by 2, S13 is equal to 1 by root 2. So now let us put all the values whatever we have achieved till now in our initial matrix. So when you substitute in the place of S11 1 by 2, in the place of S12 minus 1 by 2, S13 1 by root 2, and like that we are substituting the values for each and every parameter. So this is the S parameter of our H plane T junction. Okay. So from this, what do we understand? So we can expand the equation and we are going to apply two cases. Case number 1 is, you are going to give the signal through the port 3. So A3 input cannot be equal to 0, and we are not going to give the input in A1, A2. That is why it is written as A1 and A2 equal to 0. Apply in the expanded equation of the final matrix, then you will get the answer to be B1 equal to 1 by root 2 A3, B2 equal to 1 by root 2 A3, and B3 equal to 0. The meaning of this is, the signal whatever you send through the port 3 is not coming out of the port 3, that is why B3 is 0. Whatever signal you send through the port 3, it is splitting equally in port 1 and 2. That is why if you see, B1 is equal to plus 1 by root 2 A3 and B2 is equal to plus 1 by root 2 A3. So we can tell that H plane can act like a power splitter. This is the main application of a H plane T junction. So now let us see what is the comparison of a H plane and E plane. The basic differences between H plane and E plane is, when you take the H plane, we call it as a current junction. When you take a E plane, it is called as series or voltage. So H is your shunt or current and your E plane junction is your voltage or series junction. The second major difference is, whichever signal enters the H plane is equally split in magnitude and in phase. That is why your S13 is equal to S23. That is how we start the derivation. But in case of the E plane T junction, the signal will be split equal in magnitude but 180 degree out of phase. That is why S23 is equal to minus. That minus represents the 180 degree out of phase splitting. And the third important difference is based on the structure. So whenever the side arm is parallel to your magnetic field, we call it as a H plane. When the side arm is connected parallel or along with your electric field, it is called as the E-plane junction. So hope you understood what is the concept of H-plane, the comparison of H-plane and E-plane junction. Thank you.